right? So the nodes are all going to be the same data type, and the data is all going to be the same data type. So they are still monolithic in that sense, yes. Okay, notice I've matched here. These are all going to be nodes of strings, and these are all going to be all going to be string objects, right? So they are going to be related, yep. Okay, and copied down the line, same old types, yep. Okay, all right. Next concept that's kind of weird is, we might not think of this, but we are typically going to make these public. So the data portion and the next portion are typically made public. And that's weird for us because we've always said from the beginning of time in 142, make all your data private. Don't expose your data to the outside world, right? It's dangerous to do that. Never, never do that. But now we're saying we're going to do that, right? How do we get away with that here, right? And I'll tell you how. We make the node an internal class to the list. We make the node an internal class to the list, and we make it private, right? We make it private because nobody outside the list has any business worrying about nodes, right? Anybody outside, any client of ours, right? Anybody who's asking us to store stuff in our linked lists, are they handing us a node to store? They're handing us a student to store, or a storage unit to store, or a customer to store. They're not handing us nodes. In fact, they have no business talking to us about nodes, and we have no business talking to them about nodes because it's not their business. They don't need to know. And in fact, if they had a reference to a node, they'll probably mess something up for us, right? It's best that we keep control of our little thing and we manage our nodes because we are the list manager. We are our linked list. So nobody gets to talk to us about nodes. We don't talk to anybody about nodes. We make it a private class, and therefore, because it's only there, it makes it a lot easier to get to these things without having to have get methods and set methods. We just grab the data when we want it and manipulate the data when we want it. Because we're the only ones doing it, right? We're the only ones doing it, so it's okay. Make sense?
Cool question. So the reference and data are typically public, but other classes won't be able to mess with it because it's the node is it's going to be a private class, and that within the same, or nested class, within.
Yeah, exactly as Ben said, right? Okay. Ben said it better than I did, right? So public, if we have public class linked list, right? Of course, it's going to be generic. We'll come back again. We're not writing a lot of code today, but down here in the bottom, we're going to have private class node, right? And that node class, it is also going to be generic because, as we see, it's going to need to be, but it's a private class. But we'll see, as we see here, we're going to have public data, right? And that's going to be a generic. And then we have public next, which is going to be what? It's actually going to be another node, right? It's going to be a sibling node. So the outside world can't get to it because it's private. We can get to it from our linked list code because it's in our class. It's a nested class or an inner class. And since the data is public, we can just reach in and just manipulate those things. Because we do that a lot, right? We're going to do that a lot. It just makes all of our code cleaner, right? All of our code. Any questions there? Okay, starting to get it. We're getting there. Okay, what else? Generics we just talked about. Okay, so we've covered that. All right, so we're not going to get too much beyond that, right? But let's just make sure that we understand the rest of the concepts, and then if we pick up tomorrow on that, that's great. So let's talk about this one then, and that is, let me get rid of my pen for a second and go here. All right. So the other thing is, and we talked about this a little before, the linked list needs to maintain a reference that points to the first node. Okay. The thing that we have to see, and the little kind of hard thing at the beginning to figure out is, front is not a node. Front is a reference to a node. So because of that fact, the way that we write code around nodes is one thing, right? Moving between nodes and treating them as one thing, that's one thing. But front is always going to be a special case. First, because we always have to start there. We always have to start traversing the list from the front, right? Second, it's not a node. So front itself does not have a data and a next data to it, right? Front just is a reference to a node. It doesn't have those portions. It is not a node. So we have to treat it differently because of those two. And we'll see that in many cases, we're going to have a special case for front. We'll talk about that in a bit when we start getting more into the code, right? So now we have a picture of an entire linked list, okay? And we understand also from our previous analogies that the only reason things are kept in memory is because somebody's pointing at them. Remember the way I phrased it? Somebody loves me. As long as somebody loves me, then the garbage collector stays away. But as soon as one of those references stops pointing at something, then it goes away and everything it points to goes away, and now they're all gone, right? Sounds like to digress a little, the movie theme. Anybody seen the movie, what is it, Coco, the beautifully animated film? That's the idea about the ancestors. As long as somebody remembers me, then I'm still around in some way. Yeah, so it feels like that in a way. Okay, all right. Yeah, love that movie. Okay, so now the trick becomes, how do we traverse the list? And so our next steps are, yeah, I've got to start at the front, and how do I move from this node to this node to this node and keep moving along till I find the thing I want, find the place I want, like all of those things come in the next little bit. All right, so what questions do you have about that at the moment? Anybody?